This video is audio content only. It does not contain any video footage or images. If you are expecting visual content, please be aware. This is intentionally provided in an audio-only format. We recommend listening to the audio rather than watching the screen. Thank you for your understanding. Welcome. Prepare to embark on an incredible journey across Eurasia, connecting languages from Istanbul to Tokyo. For decades, the origins of the Transeurasian language family, including Turkish, Mongolian, Korean, and Japanese, were a profound mystery. But groundbreaking research combining linguistics, archaeology, and genetics has unveiled a surprising truth. These languages were spread not by nomadic warriors, but by ancient millet farmers. Get ready to have your understanding of history rewritten. Chapter 1. Millet, Migration, and a Linguistic Thread. Imagine a linguistic thread stretching across the vast Eurasian continent, from the bustling markets of Istanbul to the serene gardens of Tokyo. This thread connects an astonishing array of languages: Turkish, Mongolian, Korean, Japanese, and many others in between, including the Tungusic family spoken across Manchuria and Siberia. These are the Transeurasian languages, a family encompassing 98 distinct tongues, spoken by hundreds of millions today. For generations, scholars grappled with the profound mystery of their origins, a debate intensified by the fact that these languages were previously known as Altaic, and their very relatedness was a highly disputed issue. Where did such a widespread and diverse family begin? And what propelled its speakers across such immense distances, linking cultures that often appear so distinct? For a long time, the prevailing theory, often called the pastoralist hypothesis, suggested that these languages were primarily spread by nomadic, horse-riding peoples who originated in the eastern steppes of Asia, expanding their influence through herding and conquest, particularly during the Bronze Age. This powerful image, reinforced by the later historical dominance of groups like the Mongols and Turks, conjured up visions of mounted warriors, carrying their languages on the winds of their migrations. However, recent scientific breakthroughs have painted a dramatically different picture, one that rewrites millennia of human history and reveals a far more ancient and deeply rooted origin for this colossal language family, now supported by what is termed the farming hypothesis. The new evidence points not to the steppes and their pastoralists, but to a specific, fertile region in Northeast Asia, nearly 9,000 years ago, the West Liao River Valley. This area, encompassing parts of what is now China's Liaoning and Jilin provinces and the Inner Mongolia region, was not the domain of horse-riding nomads, but of early farmers. Here, a humble grain, broomcorn millet, played a pivotal role, becoming the catalyst for a linguistic and demographic expansion that would eventually span more than 8,000 kilometers. The shift in understanding this monumental linguistic journey comes from an unprecedented convergence of three independent scientific disciplines: linguistics, archaeology, and genetics. This interdisciplinary method, known as triangulation, allowed researchers to weave together diverse data and peer back into the mists of the early Neolithic period, around 9,181 years ago, to pinpoint the very cradle of the Proto-Transeurasian language. Let's start with the linguistic evidence itself. Linguists meticulously sifted through words from modern and historical varieties across 98 Transeurasian languages. Using sophisticated computational methods, they were able to reconstruct the vocabulary of the ancestral Proto-Transeurasian language. What they found was a linguistic blueprint directly linked to an agricultural way of life. The reconstructed proto-language contained a small yet remarkably consistent core of inherited words related to cultivation. Terms for field, sow, plant, grow, and cultivate were present, alongside words for specific tools like spade. Crucially, this ancient vocabulary included words referring specifically to millets, such as millet seed and millet gruel, but notably lacked terms for rice or other later crops like wheat and barley. This strongly suggested that the earliest speakers were millet farmers. Beyond cultivation, the language also held terms for food production and preservation like ferment, grind, crush to pulp, and brew, indicating a settled lifestyle focused on processing and storing agricultural products. The presence of words for wild foods like walnut, acorn, and chestnut further painted a picture of communities that, while farming, also supplemented their diet with local wild resources, characteristic of early sedentary life. Even early textile production left its mark, with reconstructed words like sew, weave cloth, weave with a loom, spin, and terms for plant fibers such as rami and hemp. And for domesticated animals, only pigs and dogs featured in this foundational vocabulary, a stark contrast to the vast array of livestock associated with later pastoralist cultures. This linguistic reconstruction provided a compelling snapshot of an early farming society, placing its origins squarely in an agricultural context. But language alone, no matter how meticulously reconstructed, needs corroboration. This is where archaeology steps in, providing the tangible evidence from the ground. Archaeologists focused their attention on Neolithic Northeast Asia, a region known for early plant cultivation. They amassed an extensive database of 255 Neolithic and Bronze Age sites, meticulously scoring 172 archaeological features for each. The archaeological record unequivocally highlights the West Liao River Basin as a key center, where the cultivation of broomcorn millet began as early as 9,000 years ago. This precisely matches the linguistic timeline. Analysis of the artifacts and cultural features from these sites showed a clear cluster of related Neolithic cultures in the West Liao Basin. From this core, two distinct branches of millet farming cultures emerged, spreading outwards. One moved towards the Korean peninsula, forming the basis of what archaeologists call the Korean Cholman culture, while the other extended into the Amur River region, Primoria and Liaodong. This archaeological narrative of early millet farming and its outward spread perfectly aligned with the linguistic story of a Proto-Transeurasian language rooted in agriculture. Finally, ancient DNA offers a biological lens, revealing the genetic footprints of these early populations. Researchers analyzed ancient genomes from 23 newly sampled individuals from Korea, the Ryukyu Islands, and early cereal farmers in Japan. What they discovered was a shared genetic component dubbed Amur-like ancestry, present across many speakers of Transeurasian languages. This genetic signature, representing the genetic profile of the ancestral population from the West Liao River region, indicates a common ancestral population whose genes were carried as these early farming communities expanded. The evidence suggests that during the late Neolithic, millet farmers carrying these Amur-related genes began spreading into neighboring regions across Northeast Asia. This genetic continuity across the vast expanse where Transeurasian languages are spoken provides powerful biological confirmation of the population movements that accompanied the spread of millet agriculture and, by extension, the language family itself. The picture emerging from this interdisciplinary research is profound. It challenges long-held beliefs, proposing that the common ancestry and initial dispersals of the Transeurasian languages were driven not by nomadic herders, but by the steady, persistent expansion of sedentary millet farmers from the West Liao River Valley. This agricultural foundation, established 9 millennia ago, laid the groundwork for a linguistic heritage that would eventually stretch across continents, connecting people from Istanbul to Tokyo. This discovery compels us to reconsider the origins of human societies and the fundamental forces that shaped our languages and cultures. It is the revolutionary method of triangulation itself, the precise alignment of linguistic, archaeological, and genetic evidence that allowed researchers to peel back millennia of history and reveal this truth, a methodology we will explore in detail next. Chapter 2: Triangulation: Unlocking Transeurasian Origins. The study of Transeurasian languages involved a revolutionary interdisciplinary approach known as triangulation, which meticulously cross-referenced findings from language, ancient artifacts, and human DNA. This method allowed each distinct discipline to validate and enrich the other's conclusions, providing a far richer and more balanced understanding of human history than any single field could provide alone. Let's begin by diving deeper into the linguistic evidence. To build a comprehensive family tree for the Transeurasian languages, researchers assembled an unprecedented data set. They gathered over 3,000 cognate sets, words across different languages that share a common ancestral origin, representing more than 250 fundamental concepts. This massive collection encompassed 98 Transeurasian languages, including not only modern tongues, but also their historical varieties and dialects. To establish the time depth of this linguistic family, sophisticated Bayesian phylogenetic methods were employed. These advanced statistical techniques are particularly powerful as they can integrate diverse data types and account for uncertainty, allowing researchers to infer a statistically robust dated phylogeny, essentially a timeline for the language family's evolution. This date marked the initial breakup of the ancestral language into its foundational subgroups. Further analysis provided dates for subsequent splits. Proto-Altaic, the ancestor of Turkic, Mongolic, and Tungusic, around 6,811 years ago. Mongolo-Tungusic at 4,491 years ago, and Japano-Koreanic at 5,458 years ago. These dates provided a precise chronological framework for the language family's expansion. Beyond dating, linguistics also helped pinpoint geographic origin and dispersal routes. By applying Bayesian phylogeography, a method that models language expansion across space, researchers could reconstruct the most probable ancient homelands. The linguistic analysis revealed distinct dispersal patterns from a central heartland. Crucially, the qualitative analysis of the reconstructed vocabulary painted a vivid picture of the culture of these early Proto-Transeurasian speakers. This meticulous linguistic reconstruction provided compelling evidence that the earliest Transeurasian speakers were settled farmers. Next, archaeology provided the tangible, on-the-ground validation for this linguistic narrative. Archaeologists focused on Neolithic Northeast Asia, a region known for its early innovations in plant cultivation. They compiled an extensive database of Neolithic and Bronze Age sites. Furthermore, they created an inventory of directly carbon-14 dated early crop remains from northern China, the Primorye region, Korea, and Japan. This rigorous data collection allowed them to precisely map the spread of agricultural practices across the landscape and through time. The archaeological record unequivocally confirmed a pivotal center for early agriculture. Bayesian analysis of the archaeological data allowed for the clustering of sites based on cultural similarity, revealing clear patterns of dispersal. From this core, millet farming cultures emerged and spread outwards. This archaeological pattern of millet farming spreading from a central homeland mirrored the linguistic dispersal routes identified through phylogeographic analysis. The archaeological evidence also tracked the evolution of agricultural practices over millennia. It showed that farmers in northeastern China eventually supplemented their millet cultivation with rice and wheat. This more diverse agricultural package was then transmitted to the Korean peninsula, and from there it spread to Japan. This detailed archaeological timeline provided concrete evidence of agricultural expansion directly linked to the geographical spread of the proto-languages. The consistency between the linguistic and archaeological records, tracing similar outward movements, offered powerful corroboration. Finally, ancient DNA provided the biological link, tracing the very movements of the people who carried these languages and farming practices. Recent advancements in ancient DNA sequencing have revolutionized our understanding of human history, allowing scientists to extract and analyze genetic material from ancient human remains.
This research involved analyzing ancient genomes from individuals across Northeast Asia, providing a broad genetic tapestry of ancient populations. By comparing these genomes, researchers identified a common genetic component, which they termed Amur-like ancestry, shared among many speakers of Transeurasian languages. Its widespread presence among diverse Transeurasian-speaking groups today indicates that the languages spread not just through cultural diffusion, but through the actual movement of people carrying these genes. The genetic evidence further showed that during the late Neolithic, these farmers, carrying their distinctive Amur-related genes, began to spread into contiguous regions across Northeast Asia.
Specific genetic findings offered fascinating insights into population mixing. This indicated a complex history of intermingling and back-and-forth migration, not just a one-way spread, further enriching our understanding of how populations moved and interacted. The genetic data thus provided undeniable biological proof of population movements that aligned with both the linguistic dispersal patterns and the archaeological evidence of agricultural spread. The convergence of these three independent lines of evidence, linguistics, archaeology, and ancient DNA, is what makes this research truly revolutionary. Each discipline, using its own rigorous methods, arrived at consistent conclusions. But how did these early farmers, tied to their fields, manage to spread their languages across such vast and diverse landscapes, reaching as far as Siberia, Korea, and Japan? Chapter 3: The Great Dispersal. Building on the established origins of Transeurasian languages, this chapter details one of the most compelling narratives revealed by this groundbreaking research, the Great Dispersal. This wasn't a sudden explosion, but a gradual, persistent outward movement, driven by the very nature of early farming and the burgeoning populations it sustained. It's a story of how a seemingly humble grain and the sedentary lifestyle it fostered became the engine for a linguistic expansion that would reshape the human landscape of Northeast Asia. Imagine the lives of these early Neolithic millet farmers. While agriculture offered a more stable food supply than foraging, early farming, especially with crops like broomcorn millet, was often characterized by relatively low yields per unit of land. This meant that to feed a growing population, farmers constantly required more arable land. Unlike nomadic pastoralists who could move their herds across vast steppes, these millet farmers were tied to their fields. Their expansion wasn't about rapid long-distance movements, but a steady, almost imperceptible push into neighboring areas, seeking fertile ground for new settlements and new fields. This continuous need for expansion, fueled by increasing birth rates and the modest productivity of their staple crop, created an inherent population pressure that propelled them outward from their homeland. The meticulously reconstructed Proto-Transeurasian vocabulary, as detailed in previous chapters, consistently paints a picture of settled communities. This linguistic snapshot reinforces how the inherent nature of their early farming lifestyle, which supported growing populations, created a constant need for new land, driving a series of migrations across Northeast Asia over millennia. The archaeological record, as discussed in Chapter 2, vividly illustrates this outward trajectory. Bayesian analysis of archaeological sites reveals distinct branches of millet farming cultures, showing a clear pattern of gradual expansion. These sites demonstrate cultural continuity through shared pottery styles, stone tools, and burial practices as farming populations moved. One significant direction of this dispersal was northwards, into the vast and often challenging landscapes of Siberia. This movement carried the linguistic ancestors of the Tungusic languages into regions like the Amur-Ussuri-Khanqa area and further into the Russian Far East. Archaeological findings from the Amur River basin, particularly linked to the southern Hung Shan culture, demonstrate how agriculture, specifically millet cultivation, was added to the existing subsistence strategies of fishing and hunting by approximately 7,000 years ago. This blend of lifeways, integrating agriculture into a resource-rich but previously hunter-gatherer dominated environment, spurred population growth in these northern regions. The genetic evidence further supports this, with studies showing a stable and continuous genetic structure in Amur River Basin populations from the Mesolithic era. A distinctive genetic component, identified in previous chapters, became a hallmark of these northern Transeurasian-speaking groups. As researchers have noted, this genetic component appears to be common to all speakers of Transeurasian languages, confirming that the expansion was not merely a cultural borrowing, but a genuine demographic movement carrying a shared genetic legacy. Simultaneously, an eastward movement introduced the foundations of what would become the Koreanic languages. Archaeological evidence tracks this movement. The introduction of Millet to the Korean peninsula around 3500 BCE is strongly associated with the arrival of these Proto-Korean speakers. This wasn't a single, dramatic invasion, but rather a sustained, gradual expansion of farming communities seeking new lands. The archaeological analysis further links these cultures with later sites in Korea, illustrating a continuous thread of agricultural development and population movement. The dispersal didn't stop at the Korean peninsula. From there, the eastward movement continued, eventually reaching the Japanese archipelago, carrying the ancestral Japonic languages. This final leg of the journey was particularly significant. The archaeological evidence suggests that after millet farming had taken root in Korea, new agricultural practices began to emerge. This expanded agricultural system then acted as a springboard for further migration across the sea to Japan. From Korea, populations carrying this advanced farming knowledge, along with their languages, began to arrive in Japan. These ancestral Japonic speakers settled first in areas like northern Kyushu, then gradually spread across the rest of the Japanese islands, transforming the existing Jomon hunter-gatherer societies. While the precise timing and agricultural associations of Proto-Korean and Proto-Japonic dispersals remain subjects of academic debate, the overall narrative of an eastward expansion driven by agricultural innovation is robust. The genetic findings further illuminate the intricate dance of populations during this eastward expansion. A distinctive genetic component is traceable not only in Koreanic speakers, but also in Japanese, confirming their shared genetic heritage. Furthermore, as discussed in Chapter 2, genetic analysis has revealed complex interactions, including instances of intermingling with existing indigenous hunter-gatherer groups and even back-and-forth movements across the Korean Strait, highlighting a more dynamic dispersal than simple one-way migration. Thus, the Great Dispersal of the Transeurasian languages was a multifaceted process, driven by the continuous imperative for expansion inherent in early millet agriculture. These sedentary farmers, carrying their distinctive genetic legacy and evolving languages, gradually pushed outwards, north into Siberia and east toward Korea and Japan. This slow, steady march of farming communities laid the foundation for a vast linguistic family. But as they spread and interacted with diverse groups, their shared heritage began to acquire new layers, setting the stage for the complex cultural and linguistic transformations discussed in the next chapter. Chapter 4: The Bronze Age Masquerade. If the shared Transeurasian heritage is so ancient and foundational, why has its very existence been debated for so long? Why did generations of scholars argue vehemently about whether these languages truly formed a single family? The answer lies in a profound historical masquerade, a complex layering of later migrations, intense cultural contact, and extensive linguistic borrowing that, for millennia, obscured the original millet farming bedrock. Imagine a beautiful, intricate tapestry woven with threads of a single color. Over time, other weavers add new patterns, new colors, and entirely different materials, creating an overlay so dense and rich that the original, unifying design becomes almost impossible to discern. This is akin to what happened to the Transeurasian language family. Since the Bronze Age, a cascade of new influences, from powerful pastoralist civilizations to advanced rice farming societies, swept across Eurasia. These interactions introduced new lifeways, new technologies, and, crucially, a flood of new vocabulary and genetic mixing that profoundly reshaped the communities descended from those early millet farmers. Let's first consider the linguistic aspect of this masquerade. While the initial Proto-Transeurasian language, as reconstructed through meticulous analysis, contained a foundational layer of vocabulary, this became increasingly obscured over time. New subsistence terms began to appear, not as inherited words from the original ancestor, but as direct borrowings from other languages. Speakers of Proto-Turkic, Proto-Mongolic, Proto-Tungusic, Proto-Koreanic, and Proto-Japonic started to adopt words related to the cultivation of rice, wheat, and barley. Even more strikingly, the vocabulary of dairying and the names for domesticated animals like cattle, sheep, and horses poured into these languages. This reflected a dramatic shift in lifestyle for many groups, particularly those who encountered or adopted pastoralist traditions from other parts of Eurasia. Along with these new agricultural and animal husbandry terms came words for new farming or kitchen tools, and even luxurious textiles like silk. These were not linguistic echoes of an ancient shared past, but rather clear indicators of intense cultural exchange with Bronze Age populations speaking various Transeurasian and non-Transeurasian languages. This extensive borrowing created a superficial layer of commonalities between languages that might otherwise appear unrelated. When linguists in earlier generations compared these languages, they often found similarities that seemed to point to a shared origin. But upon closer inspection, many of these connections turned out to be borrowed words or loanwords rather than true inherited cognates. This made it incredibly difficult to distinguish genuine genealogical relationships from aerial diffusion, where languages in close geographical proximity influence each other, regardless of their family tree. The long-standing debate among scholars, particularly regarding the Altaic hypothesis, the precursor to the Transeurasian concept, often hinged on this very distinction. Were the shared properties due to deep inheritance or widespread borrowing? The sheer volume of borrowed terms from later cultural contacts deeply masked the underlying inherited linguistic core. The archaeological record also reveals the layers of this masquerade. While the initial spread of the Transeurasian languages was intimately tied to early millet farming, the later millennia saw the introduction of new agricultural packages and material cultures. These later agricultural innovations, originating from different cultural centers, added new archaeological signatures that could easily be misinterpreted as the primary drivers of cultural and linguistic spread, further obscuring the earlier millet farming foundation. Perhaps the most dramatic aspect of this masquerade is revealed through ancient DNA. While the original millet farmers carried a distinctive genetic signature that spread with their languages, later migrations led to significant population admixture. During the late Neolithic and particularly the Bronze Age, speakers of the daughter branches of Proto-Transeurasian encountered and intermingled with other major populations. Genetic evidence indicates significant admixture with populations from the Yellow River region, who carried their own distinct genetic profiles and agricultural traditions, such as foxtail millet farming, which gave rise to the Sino-Tibetan language family. They also intermingled with Jomon populations. Furthermore, as the Transeurasian-speaking groups moved westward, they experienced increasing gene flow from Western Eurasian populations, particularly during the Bronze Age. This genetic mixing was especially pronounced among the ancestors of Mongolic and Turkic speakers. While these groups preserved some of their original genetic signature, the influx of Western Eurasian genes became increasingly significant from the Bronze Age onwards. This process was part of a broader, extensive cultural exchange that swept across the Eurasian steppe during the late Bronze Age. These interactions led to a blending of populations from the eastern steppe with Western Eurasian genetic lineages.
This profound genetic admixture meant that the descendants of the original millet farmers were no longer genetically homogeneous, making it challenging to trace their origins through DNA alone without the detailed interdisciplinary approach of triangulation.
The pastoralist hypothesis gained traction precisely because of this Bronze Age masquerade. When scholars observed the prevalence of pastoralist lifeways and related vocabulary in many Transeurasian languages, it was a logical conclusion to assume that these nomadic cultures were the original carriers. The extensive borrowing of agro-pastoral vocabulary by Proto-Mongolic and Proto-Turkic speakers, encompassing terms for wheat and barley cultivation, herding, dairying, and horse exploitation, further reinforced this pastoralist narrative. The genetic data, showing significant Western Eurasian admixture in these groups, also seemed to support a narrative of steppe-based origins or at least significant later influence. However, the historical importance of pastoralism or the role of these later migrations is not invalidated. Instead, our understanding is refined by placing them in context. While pastoralist and rice-farming civilizations profoundly influenced the subsequent development of Transeurasian languages and cultures, they were not the originators of the language family. Rather, they were later layers of cultural contact that added new elements and obscured the deeper, more ancient agricultural roots. The picture that emerges is one of dynamic interaction. Original millet farming communities expanded, then diversified their agricultural practices, and subsequently absorbed significant cultural and genetic influences from their neighbors, including rice farmers and pastoralists. This complex history of borrowing, admixture, and cultural evolution meant that the commonalities observed across the Transeurasian languages were a mixture of ancient inheritance and later diffusion. It took the revolutionary triangulation of linguistics, archaeology, and ancient DNA to carefully peel back these layers of history, to distinguish the original threads from the later additions. This revelation, however, has implications that reach far beyond academic debate, touching upon the very identities of modern nations and peoples. Chapter 5. Collision of Science and Identity. We've meticulously pieced together the ancient tapestry of the Transeurasian languages, following their gradual dispersal and observing how later migrations and cultural exchanges layered over their original heritage. This journey has been a triumph of interdisciplinary science to rewrite a vast chapter of human history. But, as with many profound scientific revelations, the implications of these findings extend far beyond academic circles, often colliding with deeply held beliefs and national identities. This makes the story of the Transeurasian languages one of the most politically charged and sensitive areas of contemporary archaeology. For many modern nations, particularly those with long and complex histories like Japan, Korea, and China, a sense of national identity is often intertwined with narratives of singular origin, an unbroken lineage, and a distinct cultural and genetic purity contained within present-day borders. These narratives, while powerful for forging national unity, frequently simplify or overlook the intricate, messy realities of human prehistory, realities shaped by constant migration, cultural borrowing, and genetic mixing. The scientific evidence emerging from the Transeurasian study directly challenges these simplified, nationalist viewpoints, revealing a deeply mixed transnational heritage that can be uncomfortable for some to accept. Consider the very notion of a shared linguistic family spanning from modern-day Turkey to Japan. To discover that the languages spoken across this immense geographical expanse, from Turkic and Mongolic to Tungusic, Koreanic, and Japonic, all share a common ancestor, is a powerful statement about transnational origins. It implies that the linguistic and, to an extent, cultural roots of these diverse peoples lie far beyond their current national boundaries. This scientific truth suggests a profound interconnectedness, a shared ancient history that transcends the political divisions of today. The linguistic evidence, overlaid by extensive later borrowings for crops like rice and wheat and animals such as cattle and horses, inherently testifies to an ancient history of dynamic cultural exchange. This linguistic tapestry, woven from both inherited and borrowed threads, directly challenges notions of isolated development and cultural purity. Genetic findings even more directly confront narratives of singular identity. The research critically reveals a history of profound admixture with Yellow River populations, Western Eurasian groups, and indigenous Jomon populations. This genetic tapestry demonstrates a far more fluid and interconnected East Asian genetic landscape than rigid national narratives often portray. The very distinction between the origins of the Transeurasian language family and the Sino-Tibetan language family also plays into this collision. This highlights that even within what is broadly considered East Asia, there were distinct and parallel centers of agricultural innovation and linguistic dispersal. It challenges any monolithic view that all significant cultural and linguistic developments in the region must trace back to a single unified Chinese origin, instead presenting a more nuanced picture of multiple interacting centers of innovation. The discomfort with these findings, as researchers have noted, stems from the idea that accepting that the roots of one's language, culture, or people lie beyond present national boundaries can feel like a surrender of identity. For powerful nations, often depicted as representing a single language, a single culture, and a single genetic profile, this truth can be deeply unsettling. It forces a re-evaluation of national myths, suggesting that the very essence of a people is not static and pure, but dynamic and mixed. This is why the scientific narrative of deeply mixed transnational origins becomes politically charged. It asks nations to embrace a more complex, shared history, one that acknowledges the constant flow of people, ideas, and genes across what are now politically defined borders. The science of human history consistently reveals that the story of all languages, cultures, and peoples is one of extended interaction and mixture. This is not a phenomenon unique to East Asia, but a universal truth about humanity. Recognizing this complexity, however, requires a shift in perspective, moving away from rigid, isolated national frameworks towards a more flexible and international understanding of prehistory. It encourages us to see our shared human journey as a grand, interconnected narrative, where every thread contributes to the richness of the whole. As archaeologist Mark Hudson notes, there is still so much to learn, underscoring that the story of human history is an ever-unfolding, complex narrative of constant interaction and mixture. The findings compel us to consider how this deeper, more accurate understanding of our complex past might shape our collective future, particularly in regions where historical narratives continue to influence geopolitical relations. Our journey through the Transeurasian languages reveals a profound truth. Their origins lie not with nomadic pastoralists, but with ancient millet farmers from Northeast Asia, whose gradual expansion shaped a vast linguistic family. This revolutionary discovery, powered by the triangulation of linguistics, archaeology, and genetics, peels back millennia of history, challenging long-held theories and national narratives. It underscores that human history is a complex tapestry of constant interaction, migration, and cultural exchange, far more interconnected than often portrayed. This deeper understanding of our shared past invites us to embrace a more nuanced view of identity and heritage. Thank you for listening.